Good afternoon, class. My name is Elijah Whitesell, and my partner is,
My name is Qinfu.
and we are doing our proposal presentation on the wind tunnel drag lift apparatus, in which we chose as our capstone project. Before we go into some of the details of this presentation, we're going to give a little background on it. And so the original iteration was designed and fabricated and manufactured by Alexander Titlin, who was a senior student back in 2020. And he worked on this project with Miss Wickett, and he was trying to make an apparatus into which we can test the drag and lift of different shapes and different objects in our big wind tunnel in order to have another device for our fluid labs. And so he originally had a timeline and he had a budget set for it, and he had fabricated all the parts by December 2020. And he ran out of time in order to put the actual device together and test it, and the functionality testing. And so technically, this device was not completed back in 2020, but the majority of it was finished by 2020, and he had completed the majority of the work, and he did all the write-ups for it. And so a couple students later, the last student to have it was Irfan Ahmed, and Irfan, from the previous students' testing and their conclusion was that the device was too noisy in order to use it as a fully functioning drag lift apparatus. And so Irfan had developed an amplification circuit for it, and to which he was going to test, but he also ran out of time. And so the device was left as a fully put together noisy apparatus that needed to be refined. And so that brings us kind of to where we are today, and to kind of why we picked it up as a project, as an apparatus that we should be able to use to test the drag and lift of different objects in our fluid lab. And so the project goal, as you can see, is to redesign the first iteration of this apparatus. And from the previous students' explanations, the first design was very rudimentary in its design, and it didn't have optimization when it comes to friction reduction, and tolerancing was very sloppy. And so there was a lot of play in between the different components of these parts. And so this hopefully will lead to a reduction in the noise when we optimize it and we add bearings onto the different components, and we redesign some of these components in order to provide a more streamlined design and offer less friction in the overall system. And so part of this noise reduction is going to be fabricating a stand for it. This hopefully should isolate much of the wind tunnel noise from the AC motor that is powering the turbine, which is moving the wind, the air, the fluid through the actual wind tunnel. And so fabricating a stand should help isolate this noise from the wind tunnel, from the actual drag lift apparatus, hopefully eliminating the majority of the noise in the overall system. The original mounting system was very rudimentary and offered no dampening in the system whatsoever. And so it was direct metal on metal contact from the drag lift apparatus to the wind tunnel. And so this we assume is where most of that noise was coming from. And so making this stand for it should reduce most of this noise. The last component of our project is to integrate the wind velocity measurement onto the actual sting. And so not onto the sting, but onto the connecting rods that connect to the sting. And so this should help streamline the system and also add more functionality to the system overall. So for our project timeline, from the end of September onto early October, we should finalize the 3D models. We should have purchased the pitot tube for integration, and we should have troubleshotted and diagnosed the main components of the main problems of the first iteration. And so from October 3rd to October 15th, we should fabricate the optimized components, finalize that fabrication, and then begin the stand production and fabrication. From October 15th to October 30th, We should test the refined design and the integrated pitot tube functionality. And we should adjust these components as necessary in order to optimize the system overall and create the best edition that we can create in order to make it, up to par for the actual lab testing. And so from November 1st to November 15th, we should write the program for LabVIEW, refine the program as problems arise within the system, and create a fully functioning program in order to take the data that comes out of the testing apparatus and produce it and view it in a fully optimized way in order to be functioning for testing purposes for the fluid lab. And then November 15th to November 30th, we should finish with writing the final report and come up with all the data and the testing that we've done for it, and produce that in a organized and logical manner in order for people to read.
And there's a internal market analysis. We know that internals are essential for evaluating aerodynamics. At the same time, the device for various data detection is very important for the internal. So, and the growth in electric vehicle sales since COVID-19 crisis has led to increased demand for high quality internal solution for electric vehicles, especially in the US, China, and Europe. While the global internal market initially collapsed due to the COVID pandemic and related regulations, the market is expected to recover strongly due to growing demand for internal across in multiple end-use verticals. And regionally, the internal market in the Asia Pacific is expected to witness the highest growth over the next 5 years. Countries such as China, India, Japan, South Korea, and Australia are investing heavily in local development plans that will be growth engines of the region. Next one, please. And based on the type of application, the market is segmented into 6 segments. The aerospace and the defense application segment dominated the market in 2018, and it's expected to maintain its dominance over the focus period. And globally, the above 9 companies account for the vast majority of the internal markets. Next one. And for the literature review, this paper presents a internal balancing design to meet the needs for a reliable but more affordable device that can perform precise aerodynamic measurements in 3 axes and is designed to have little interference with the ducts in the internal airflow. The device is designed to be easily transported and disassembled. In addition to being easy to calibrate, as it may sometimes be necessary to use it in different internal laboratories. And here is our references.
And so this is our time for question and answers, in which we will have time in class tomorrow for the questions and answers. Thank you guys for watching our presentation, and we will answer your questions tomorrow.
Yeah, thank you.